For the end-to-end test, we are going to use a client-side library that it's called Custom.js. Custom.js is a JavaScript-based package. Actually, it's a group of packages that allows to perform different operations on Cosmos SDK chains, like signing transactions, then some cryptography packages, and also for encoding and math. So here you have the repository for Custom.js for your reference. So let's set up our repo to use this. For this, we're going to create a client directory. If you are developing your own chain, you may want to have this client directory on another repo where you will have all the client-side code there, including some front end and this type of logic that we are going to add and some wallet integrations. And within this client, we are going to create an npm package. So let's run npm init. Just for your reference, I'm using Node version 22.2 and npm 10.7. So let's run npm init. We are going to call this RPS chain client. You can put here whatever you want to put, some information about the repo, and that's it. Now we have our package.json created. Here we are going to install the dependency ts_proto. That's going to get our proto files into TypeScript. We're going to see now how we can generate this, but for now let's install this dependency. There we go. And now we'll create a directory called scripts, and within this script we are going to have a script that will generate our proto files in TypeScript so we can interact with our chain. Let's create a file called protogen.sh. And this is going to be obviously a bash script. User bin bash, where we're going to cd to the root of the client folder, and we're going to get the RPS chain protos. To do this, we are going to create some directories within our client to be the proto, lb, and RPS. That's our module. And we are going to copy all the proto files within the proto directory that we have in our root. RPS v1, and we are going to copy this to the proto lb RPS within the client. For this to work, we will have also to include all the dependencies of our protos. So I'm going to add real quick the corresponding logic to get all our dependencies. So here I added the corresponding dependencies that we have with the Cosmos query v1, the same for the message v1, and we are going to pull the corresponding protos for the Cosmos SDK version that we are using. We're also using this Cosmos proto and some Google API, the annotations and the HTTP, and the same for the descriptor and the Gogo proto. Remember, all these are dependencies that we have, for example, in our transaction proto. You will see all these dependencies that we have. These are the ones that I'm pulling here from the corresponding repo. This is just pulling the proto files that we are going to use then, to compile it. And to compile it, we'll need to install the protobuf compiler. And we're going to pass this plugin that we already installed, that is the TS Proto, to generate our TypeScript files in this path. So we can also create this in case it is not yet created. We'll create the source types generated, and it's going to be located within our client. It's going to put all the TypeScript files for our protobuf. For this to work, we have to install the protobuf compiler, and this one can be installed. If you go to the official documentation, you will see some steps for installation. In my case, I'm using Linux, so I can just run this command with sudo permissions. And once this finishes, I should be able to get some version here. All set. And now we can run this script to generate the corresponding files. Make sure you are within the script directory to run this, otherwise your files may be placed somewhere else. Also, if you are using Linux, make sure to change the mode to execute for the protogen script. There we go. Now we can execute it. And we run protogen sh. This is going to pull all the files that we need and generate the corresponding files. So you can see here in the proto, we have all the proto files that we need. And in the types generated, we'll have the corresponding TypeScript files. For example, here you have the messages. We have all our types defined now. Before continuing, I'm going to add this in a commit so you have it as reference instead that you want to have it there. So let's add git commit message setup client and generate protos. And we'll push this to the lesson 6. The next step is to create a Stargate client that is used to interact with our module. To do that, we will first close everything here and create within our source a new folder called modules, where we are going to have all our custom clients for the different modules. And we'll create a new folder here for our RPS module. And we will start with the queries. Queries.ts. And here we will have an interface that's going to be called RPS extension for our module, where we'll have a read-only RPS that it's going to have some read-only functions. The getGame, that's our query for querying the stored games, where we have the index, that's number, and we will return a promise of a game. The game we already have it defined in our generated proto files, game or undefined. Let's import here the game. For now, from we have here RPS v1, and this defining the RPS one. Let's format this with prettier, and we will also have the get params Now within our queries, remember we have the getGame and the getParams, and this will have nothing as input and will return a promise of params. It's from the same. And after we have this, we can have a function to set up this extension. Export function setup RPS extension. We will have a base query client, and we'll return RPS extension. This query client comes from Stargate, and to use this we'll have to install first npm install at custom.js Stargate for it. And the other package that we are going to need is the Tendermint RPC for connecting to the client. There we go, we have these two already. And now we can use the query client. Import query client from custom.js Stargate const RPC create proto buff RPC client. This is also from Stargate that allows us to create clients. We are going to use the base query client, and then we'll have a query service. It's going to be a query client implementation. Remember, this is from our queries. This query client implementation, if you remember, it's defined in our protos. So this will be from query. A typo here. There we go. And then we'll return an RPS, rock, paper, scissors. That's getGame. It's going to be an async function with index as a number, the input parameter, and the promise is the same here, what we return. And the function, the implementation for this is going to be the following. We have the response, and we are going to query service getGame, and we'll have the index that's a long from number index, and this will return the response game. And I think we need to import this. The next function is the getParams. The getParams has this signature. It's also an async function that returns this promise. And the implementation of this is very similar to the previous one. Response, await, query service, getParams. No input parameter, this is just an empty. And we are assert, we'll return here the rest param. Let's format this. And this is it for the queries. Now we'll have to create the Stargate client and plug these queries. To do this, we will create within our source, we'll create a new file called RPS from rock, paper, scissors. underscore Stargate client.ts, and this is going to be a class RPS Stargate client. That's going to be our client to interact with our custom module. Extends the Stargate client class. So let's add the import here. I can type. There we go. And this will have a public read-only RPS query client. That's the one we just refined. That's going to be RPS extension, undefined. And we'll have protected constructor where we will set up this client. I will need a comment client. That's going to be a comment 38 client, undefined, and some options. That's going to be some target client options. By default will be empty. Target client options are also within the target client package, and this import is from the Tendermint RPC package. There we go. If you ask yourself why is Comet 38 client, if you check our Go mod, we're using Comet BFT version 038, so that's why we're using the client Comet 38. Otherwise, there may be some compatibility issues if you use another client. I think you have like Tendermint clients, Tendermint 34, Tendermint 37. So yeah, make sure if you are building your chain and you have a different version and you're using this, to use the corresponding client. Now that we have these input parameters defined, call the constructor comment client and options for the target client class, and then for our specific class we'll set the RPS client to be query client with extensions, and this query client comes from Stargate. And we here add our extension, that it's the setup RPS extension that we set previously. We're extending the base query client, and we'll add another function here to connect the client static async connect function, where we'll have the endpoint as input and some options for Stargate client options. And this will return a promise for RPS Stargate client. And we'll have the comment client await the comment 38 client connect to the specified endpoint and return a new RPS target client with the comment client and the options. This will connect our client and return an instance of our client to interact with the module in the blockchain itself. Okay, we have now everything set up now to perform some queries using a client-side library to our node. We can write some tests for our queries. Now that we have our queries on our client defined, we can start creating the setup for our end-to-end tests. For that, we are going to do so in a separate directory within the root of our project. We'll create an end-to-end E2E directory, and this we are going to initialize an npm package here, and we are going to make the setup to run some TypeScript tests using Jest. So to do so, we will run the npm init. Within the E2E directory, package name is going to be rps chain end-to-end tests, and we can leave the same as default. Everything's okay. And now we have a package.json created here. Then we'll have to add all our dependencies. We are going to add some dev dependencies, for example, TypeScript. Also, we want the TypeScript configuration, tsconfig for node 22. I'm using node 22 in my case. If you have a different version, make sure to use the corresponding version for you here. We're going to install as well Jest and TypeScript Jest.env to have an environment where we can define our variables for the testing. And also we will add the Jest types Jest and the Jest globals. Let's install this. Types Jest. Oh, it's not a dash but a slash. And we also need to add a few dependencies more. We'll need the Stargate, the Tendermint RPC from custom.js to interact with the node. Similarly as we did previously in our client, we need the Tendermint RPC dependency. And we are also going to use the client that we just defined. So we'll install the client package within our repo. Then you see that we imported the RPS chain client from our client directory. Now that we have all our dependencies, let's start defining the environment. So we can create here a .env. We are going to have just one variable at the moment, RPC URL. That's going to be our RPC endpoint, localhost 26657. Then to pick this up, we will create a new file called environment.d.ts. It's going to be a global environment with the namespace Node.js interface process environment, and we'll have the RPC URL string. This is going to be our process and type. We'll export this. Then we'll have to add a config for our Jest tests. file called just config.js, and we'll use module exports preset ts test test environment node configure to be prettier. There we go. We'll have to add here an annotation. Then it is the following: config with TypeScript. And the last configuration file is the TypeScript config. So we'll have tsconfig.json, where we're going to be extending the configuration that we imported from the dependencies, tsconfig node 22 tsconfig JSON, and adding all these default compilers configuration for TypeScript. Now that everything is set, we can start with the test itself. We can go to our E2E directory and create a new folder that we're going to call it tests. And within our tests, we are going to add first our get game.test.ts. First, we're going to import our environment from .env. This what's going to do is going to load our RPC environment variable. And we'll need also the environment type. So we'll use this syntax for the test: describe game, and the function here will add the logic for our tests. Our client is going to be RPS target client, the one that we previously defined, and RPS, it's our RPS extension, RPS. This is the type of our client. So before all, for all tests from just globals, describe for all from just globals. Before all, we're going to run an async function where we are going to get our client, RPS target client, connect with our process and RPC URL that we have in our environment variables. And RPS is going to be the client, RPS query client, RPS. This is our RPS extension. And once we have this defined, we can start writing our test cases. So we can use the it from just globals cannot get non-existent game, and we will query for a game that's not already created. And we are going to use this await RPS get game with index 100, and obviously this will not exist, so we'll expect game to be undefined. Another query test that we can write is the get params. So let's do that. Get params test.ts. Very similar to the previous one. And instead of can get non-existent game, it should be can get params. And here we'll use get params. And this is going to be our params. And expect params TTL to number to equal the default one is 20, so it should be 20. And in order to test this, we'll have to spin up our node and run these functions. And to run this within the test script, we can just write just verbose. So let's try this out. Let's go to our repo and build with the latest changes, make install. Make init to initialize a new chain and start the chain. Now we have a node up and running that's going to spin up an RPC node, so we can try now to run the tests. And we see that both fail. Let's see what's the problem now. Okay, for some reason I didn't have these dependencies, but just run the npm install for these two dependencies. The linter to be fixed, and now we can run the test in the end-to-end directory npm test, and as you can see, both tests are passing. Now go ahead and do the same for the transactions. Remember that you will first have to include the modules transactions here in the client, and then you'll have to go to the end-to-end test and create the corresponding tests. To add the transactions to our client, I added this RPS signings target client, where we can have here all the logic used for signing and submitting transactions to the node. As you can see, it's a little bit more complicated than the query client, but let's go real quick through it. First, we have to define some RPS types that are going to be merged with the default registry types that's from the target client. And these types is just an array of the type URL of our different messages and the generated type that we got from the proto-generated and messages file. And you will find here as well some helper function to check if the messages are encode object, and the definition for these encode objects. That's just having the type URL and the value that's the generated message. Then also we have here some helper functions related to events to get different events and event attributes. For example, here we have the get make move event, where we can get it from the response from the delivered transaction. We can look for the specific event and return that event. And we can also get, for example, specific fields, in this case the game ID, when a game ends and emit the game ended event. We may want to get the game ID that ended, so this helper function can be useful for any client-side application. By going back to our signing client, here we have the default registry that is just the the 4 registry types from Stargate plus the ones that are specific to our modules. And then we have this signing Stargate client that we use in our RPS signing client. We extend this class and this is pretty much the same as the query client. And then we have to add this connect with signer function where we connect and then we return here an RPS signing client with the registry that we defined previously, so we can sign encoded transactions and messages. And then we can define some functions to create a game, make move, and reveal move that are quite straightforward. We just have to define the message here that we are going to have the encoded object of the message with the type URL and the corresponding values and fields. And then we will use this sign and broadcast transaction function that's from the signing Stargate client. And we'll have to put here who's the signer, the message or messages, and if we want to add a fee for a transaction and a memo. And this is repeated in the make move and the reveal move. For this to work, you will have to add this new dependency for proto signing, but that's it. That's all the code that you need on your client side to sign and broadcast transactions. And for the end-to-end tests, I defined this playgametest.ts, where we are submitting some transactions to create a game and play a game. And to do this, we'll have to add a couple of dependencies. We'll need to have also the proto signing and the Stargate dependencies. And as you can see here, we have all the configuration. I also added some new environment variables. I added a specific mnemonic for Alice's and Bob addresses. This is required to make our test easier, in the sense that we will have a deterministic address for Alice's and Bob when we start a node. And for this to happen, I modify the init script, where we'll load the mnemonics from the .env file that we have in our test. That's this one. So I added these mnemonics, and then in our script we're loading those mnemonics, and then change here slightly the init script to use the mnemonics to create the keys for Alice and Bob, so they are always the same addresses, and also increase a little bit the balance for each of the accounts for the tests. But that's just the small changes in the init, so we have deterministic addresses, and we can use these in our tests. So as we change the .env of our E2E folder, I also updated here the type for environment, where we have the mnemonic and the addresses for Alice and Bob. And this is what I am using here in the play game test. I'm getting the RPC URL that we're going to use to connect to our node, and also Alice's and Bob addresses. And we'll get the signers using this function that we define in the client. If we go to our client, I define this in the source util, that you can get the signer from the mnemonic. So now that we have the mnemonics, we get the Alice and Bob signers, and we check that the addresses are the ones that we have stored in our environment. This is just safety checks. And then we create here, we instantiate one client for signing transactions from Alice, and another client for signing transactions from Bob, and the RPS extension as well that's used for queries. And before all, we create the signing clients, one for Alice, one for Bob, and the query client. And then we'll check the initial balances. This is again a safety check, where we get Alice client, get balance from Alice address in RPS. This is the nomination. If you look, the balance is the address and the nomination. And this, we expect it to be this number, because when we initialize, Alice is the validator, so it bonds some coins here. So the expected balance is this initial balance minus this one, and Bob's balance is this exact same number. We're validating that the initial balance is the expected one. And then we start performing our tests to create a game here. So as you can see, we can use, if we want to create a game from Alice, we'll use Alice client, create game, and the creator is going to be Alice. The opponent is going to be Bob, that this is an address that we previously stored, remember, here and here. And 3 rounds, and the fees we wanted to be auto-calculated, and then we wait for the response. This is going to submit, broadcast the transaction, and wait for the receipt. And once we have the response, we can check for the events. We can use the helper function get create game event and check that it is defined. And we can get from there the game ID, validate the game ID with the stored game in state as well. Here we're using the RPS, that's the query client that we defined previously. We can get the recently created game and check all the fields. And then we have a function here to make a move in the recently created game. We have the game ID that we get it from the create game transaction. And we will use the generate hash function to hash the move. In this case, it's a rock. And we will add this default salt to generate the hash. And we'll submit the make move from Alice. And we'll check that the response code is OK, which is 0. And we'll check for the make move event. And we can do the same with Bob. Using Bob client, Bob is going to submit his hashed move. And we can check again that the transaction went through successfully. And after this, we can check that the game was updated properly. And we will look for the game ID, and the player A and player moves are both have one move. This is the timeout that we'll have to increase it because all these transactions will take some time to broadcast the transaction and include it into a block. So let's test this now. If we go here, we can do the making it again. So we pick up the changes that we did in our init script, and we can RPS G start the chain. And to run this test, we'll do npm test. And we have it there. The queries that are passing as before, nothing new there. And running the play game tests. As you can see, it created a game and both players played the first moves. We can actually, if you want to check manually, we can look into the game created. RPS game 1. You can see that we have one game created and we have 2 moves, that the ones that we submitted. I'm going to push these changes to our lesson 6 branch. So let's add all these changes. Actually, let's separate them into the changes that we did in the client and in the tests. So we're including this for the client. I will say add transaction logic to client, and we'll add all the test related things, changes in another commit. Add RPS module transaction end-to-end tests. And that's it. Let git push origin lesson 6.